Here I'm providing an introduction to organic chemistry. Organic chemistry is the most important branch of chemistry in the modern world. It's primarily because there are so many molecules that are organic. Organic molecules are based on carbon, and carbon is a very versatile element in bonding. It makes 4 covalent bonds, each atom does, and therefore we can make millions, perhaps billions of different molecules based on carbon. They often have hydrogens attached, usually do. So the organic molecules are varied, and because of the versatility of carbon and because of the ability of it to make many carbons in one atom, maybe thousands of atoms make up a single molecule, this gives us a wide variety of organic molecules. Organic chemistry is intimately related to biochemistry. The chemistry of life is based on carbon molecules, so based on organic chemistry. And many of the variety of organic molecules are important biomolecules. Some of the things you've heard of probably are carbohydrates, proteins. Those are organic molecules. And the other thing that is important in the modern world that's based on organic chemistry is the chemistry of polymers. Our world is a world of plastics, and plastics are made from carbon chains. Carbon chains are sometimes called polymers. Poly meaning many, mer meaning parts. So certainly our modern world is vastly dependent on organic chemistry. Organic structures are very important. Names are not so important. It's important that you be able to draw what is the molecule we're talking about, what is the molecule you're dealing with. And this first example should look familiar to you. It's hexane. You worked with this in sophomore chemistry. It has 6 carbons. Each one is tetrahedral. Should remember how to draw that tetrahedral shape with 3 dimensions. The wedge coming out towards you, the dashed line going back away. But often chemists will not draw this structure in all its detail. It takes too long to draw. So there's a simplified way to represent organic molecules that you need to become familiar with. In the simplified model of hexane, you just draw this squiggly line. There are 6 points on this squiggly line representing the 6 carbons. Hydrogens are not shown at all. So you count the vertices: 1, 2, 3, 4, 5, 6. And that represents 6 carbon atoms, all bonded to each other with single bonds. There's no double bonds in this structure. You must understand there are hydrogens attached to each of these carbon atoms. The chain need not be, in reality, stretched out. It could be wrapped around like this. But you still see 6 vertices, 6 points, 6 carbon atoms. So it will be important you learn how to read the simplified structure and to draw the simplified structures. For the second example, you see, again, a very common structure. Should recognize this from sophomore chemistry. It's a ring with 6 carbon atoms in it. Could be called cyclohexatriene, but it has a common name, which is benzene. So benzene rings are very common in organic structures, organic molecules. And therefore it's something you want to recognize when you see it, hopefully be able to name it, and be able to draw a simplified version or to recognize the simplified version when it's presented to you. So you make a hexagon, and if you draw in these 3 slashes, that represents 3 double bonds within the molecular structure. Cyclohexatriene. triene. Sometimes this is simplified even further. Hexagon with a ring indicates a benzene ring where the double bonds are actually fluid. They can move. They are resonating. So look for this when you see it. 6 carbons, 6 hydrogens. Often there are substituents on the ring where hydrogens are replaced with other atoms. This third example you might be able to think on your own before I show you the answer. So try to think about it. So first thing you look at is 3 carbons. So 3 carbons means a zigzag with 3 vertices, and that represents the 3 carbons and their associated hydrogens. There is an OH group on the middle carbon. That has to be shown as an O and an H. And that's it. That's the representation of this molecule. Its name is isopropanol. You probably have some at home. It's rubbing alcohol. It's also in hand sanitizer. The chapter I assign you to read spends a lot of time naming molecules, and although it's not the most important part, it is important that you know some rudimentary skills in how compounds are named so that you're not stumbling over the words and not totally confused when somebody says methyl ethyl ketone. So these 4 letters are used when we're talking about small molecules, M, E, P, B. You want to make an acronym out of them, but let's first define what they mean. First letter here, M, stands for methyl or methane. If you're English, you say methyl instead of methyl. And what this will mean when you see the word is something with 1 carbon. Methane, you should remember its structure. Nice tetrahedron, CH4, very common molecule. And so anytime you see methyl or methane, think a 1 carbon structure is indicated. The second letter here is E. And E stands for ethyl or ethane. Again, if you're English, you say ethane. This will be 2 carbons. So ethyl alcohol is a 2 carbon alcohol. Methyl alcohol is a 1 carbon alcohol. Third letter is B. That stands for propyl or propane. Should remember propane from sophomore chemistry. 3 carbons. Propane is a nice fuel, C3H8. You transport that in canisters, pressurized canisters, so it's a portable fuel for barbecues and lanterns and the like. And the last letter is B, and this stands for butyl or butyl. Butane is also a common fuel, portable fuel, and this will have the indication of 4 carbons. So you want to recognize MEPB, methyl, ethyl, propyl, butyl, and it will help perhaps to have an acronym saying, well, MEPB, how do I remember the order? Since it isn't really logical. Dalton Combs, who was a stellar student at Laguna Beach High School and pursued a PhD at USC, said his way of remembering was my elephants, probably bisexual. So you can make up your own acronym for MEPB, thinking that the order tells you 1, 2, 3, 4 carbons. After methyl, ethyl, propyl, butyl, it becomes systematic. Penta or pentyl means 5 carbons. Hexa means 6 carbons. Octa, octane, 8 carbons, etc. So if you have some education, the rest of it will be easy. But this first part you'll have to memorize. So if we look up at the previous example, isopropanol, you should see the word propane in there, and that is because it has 3 carbons. So that's an example of how these methyl ethyl propyl butyl become useful when identifying molecules.